Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle, and it's called Rainbow Fishes by Evan. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Anyways, on to today's rules. Normal Sudoku rules apply, which means fill each row, well, we'll get a column there, column and box, we can get a box too eventually, with the digits 1 through 9 without repeats. Renban lines. Pink lines must contain a consecutive set of digits in any order without repeats. So for example, if this were a 1, this would have to be 2, 3, and 4 in some order here, because there cannot have repeats. And the only set of four consecutive digits with a 1 would be 1, 2, 3, and 4. Right? So remember, the lines, or on a Renban line, you have to have a consecutive set of digits without repeats. And that's how Renban lines work. Region sum lines. Box borders divide blue lines into segments with the same sum. So for example, these two cells would have to equal the sum of these two cells, which would equal the sum of these two cells, which would equal the sum of these two cells. Similarly, these two cells would have to equal those two cells, and these two cells would have to equal those two cells. So you could have something along the lines of, say, 4, 6, and 4 and 6, because they both add up to 10, and you can have repeats on a line, so you don't have to, on all these lines, actually. So that's how region sum lines work. Of course, this could also be something along the lines of 4, 6, and 3, 7. The sums just have to add up to 10, right? But I was just showcasing that you don't have to have unique digits on the line, aside from the normal Sudoku rules. So that's how region sum lines work. German whisper lines. Two connected cells along a green line must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9, since those are the only digits that are 5 away from 3. And that's how a German whisper line works. Dutch whisper line. Two connected cells along a orange line must have a difference of at least 4. So it's the same as German whispers, except that the difference is 4 instead of 5. So if this were a 3, this could be a 7, an 8, or a 9, because it has a difference of 4 between 3 and 7, 8, and 9. And that's how Dutch whisper lines work. And then finally, we have killer cage, or actually, it's not finally. We also have killer cages. So these two digits in a cage must sum to the number in the top left corner of that cage. So for example, these two digits would add up to 9. So an example here could be 2 and 7, and that would work. And these digits must add up to 13, these must add up to 11, these must add up to 4, etc., etc. And that's how killer cages work. And finally, we have black dots separate two cells with digits in a 1 to 2 ratio. Not all dots are given, and these are called black crop key dots. So for an example, if this were a 4, this would have to be a 2 or an 8 to maintain the 1 to 2 ratio, because black dots separate two cells with the digits in a 1 to 2 ratio. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first things first, I see the 16 cage, so with 2 digits, so therefore it must be specifically 7 and 9. That leaves this cage, which could only be 4, 9, 5, 8, and 6, 7 to add up for 2 digits to add up to 13. But 7 and 9 are eliminated because of the 7-9 pair in the row, so this cannot be 4, 9 or 6, 7, so it must be 5 and 8. this two cell cage adding up to 4 must be 1 and 3. And this is 5 or 8. So, remember, these two digits must sum up to what these two digits are. This can either be, if this were 3 and 8, this would have to be 1, but then this would have to be 10 to add up to the same. So this cannot be 3 and 8. If this is 1 and 8, this would have to be 3 and 6. But then the problem is this 9 cage would have to force this to be a 3. So this 1 and 8 doesn't add up to any. This 1 and 8 adds up to 9, but that would force this to be 3, 6, and 3, and that would violate normal Sudoku rules. So this cannot be 1 with 8. Can it be 1 with 5? If this is 1 and 5, this would have to be 3, but then it would add up with 3 to add up to 6, which is not possible because that would violate Sudoku rules too. So this can never be 1. So this has to be 3. This has to be 1. Again, this cannot be 8 because then that would be 10. So this has to be, this has to be 5, which makes that an 8. So this must be 1 and 7 to add up to 3 and 5. Therefore, this is a 2. So now we know what these are. These digits are all consecutive. This can only go 1, 7, 1, 7, 2, 6, or 3, 5 to add up to 8. But the problem is if you have 3, you can never be on a renban, a 4-length renban with 7 or 9, right? 3 goes only up to 4, 5, and 6. So therefore, these cannot be 1, 2, or 3. If this is 4 and 9, that would you cannot have a 4-digit renban with 4 and 9. If this is 6 and 7, that would force this to be 5 and this to be 9. So this cannot work. So this has to be specifically 5 and 8. And 5 and 8 has to have a 6 and a 7 on the renban. So this must be 6, which means this must be 7. This 6 has to be with a 2, and this 7 has to be with a 9. Okay. What else do we have? 7 cannot be here or here. This digit is next to 4 other unique digits on a German whisper line. But it cannot be 9. The only possibilities are 1 and 9, right? 1 can be next to 6, 7, 8, 9, and 9 can be next to 1, 2, 3, 4. But since this cannot be 9, this has to be then 1, which means it must be next to 6, 7, 8, and 9. Well, this can't be 6, 7, or 8 because of the 6 and the 7 and the 5, 8 pair, so this must be 9, which means none of these can be 9. We also know that the 5 cannot be any of these cells, and this sees 2 unique digits on the German whisper line, so and they have to be 6, 7, or 8, so this is 2 or 3. So the remaining digits here cannot be 5, have to be 2, 3, or 4. And this must be a 5, because that's the only place left for the 5 to be in this column. Oh, this can't be 3 either. This has to be, this will see specifically 7 or 8, at least. Or sorry, at most, essentially. And therefore, 3 cannot be next to a 7 on a German whisper line, so this must be 2, which means this can't be 2. This 2 has to be next to specifically 7 or 8. It cannot be next to a 6, so this is 6. And the remaining digits now are 1 and 2 here in column 7. So 1 and 2 cannot have, it's 8 in length, right? So it cannot have a 9 in the rest of the column. So it must have 3 through 8 in the rest of the column. So this is 3 through 8, or sorry, the rest of the line. So this is 3 through 8, this is 3 through 8. This digit is in a 1 to 2 ratio with another digit, so it cannot be 5 or 7. And it can't be 8 here. This can't be 6, and this can't be 6. This 3 could be in a 1 to 2 ratio with 6, so that would be 1. The 4 can be in a 1 to 2 ratio with 2 or 8, but specifically 8 doesn't work because 8 doesn't add up with another digit to add up to 7. So this would have to be 2 and 5. And if this is 6, that's in a 1 to 2 ratio with 3, and that could be with 4. Okay. This can't be 2 because of this 2, so this is a 1, which makes that a 2. This renban can never have a 2, so it can also never have a 1 either. This can't be 7 because of this 7. So this renban has to start with either 3, so it could be 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, or 6, 7, 8, 9. Well, none of these can be 6, so it would require a 6 every single time, right? Because it cannot have a 2. So again, it could be 3, 4, 5, 6, which requires a 6, 4, 5, 6, 7, which requires a 6, 5, 6, 7, 8, which also requires a 6, and 6, 7, 8, 9. So therefore, this must be a 6 here. So this is a 6. This can't be 6. This can't be 6. Where is the 6 then? It has to be one of these two. The 6 could be 7, 8, 9. It could be 3, 4, 5, 6, 2. We're not sure though. Okay, let's see. What else do we have? The remaining digits in this row have to be 3, 4, 5. This can't be 7, so this is 8, which makes this a 7. So this can't be 7. This can't be 7. One of these 3 is a 7, but that doesn't really eliminate possibilities here. The remaining digits here are 3, 4, 5, and 6. And 5 cannot be next to a black crop key dot. So if this is 3, this could be 6 and 5. That works. If this is 4, it cannot be 2 here because that's a 2. But it could be 8 here. And 8 works with 3, but that doesn't work then. So this cannot be 3, 8, so this can't be 4. This could be 6, in which case this is 3, and that's 8. Either way, we have now a 3, 6, 3, 6 pair in box 2, which eliminates all 3s and 6s from the rest of the box. So this cannot be 3, 6, which means this has to be 4 and 5. Well, 4 and 5 pair in this row means the rest of the row cannot contain a 4 or 5, so this can't be 4 or 5. So this is 3 or 6. What about the remaining column of this column 3? So that has to be the odd numbers, so 2, 4, 6, 8 plus 9. So this would be 4, 8, and 9, because it can't be 2 or 6. This would have to be 2, 4, 6, and 9, and then these would be 2, 4, 6, 8, and 9. And this can't be 2 or 6. Okay. The remaining digits here have to be 3, 4, 5, or 8. Well, what are the possibilities here? It could be 3, 4, and 5 with 3, 4, and 5. So this would be 3 or 4. Either way, the 5 does have to be here, right? You can have 5 and 8 here with 7. That's also possible. But either way, you need a 5 here. So this cannot be 5, and this cannot be 5. Which means one of these three is a 5, because now we have a 3, 4, 8 triplets on this Renban, which eliminates 3, 4, and 8 from the rest of the Renban. So this has to be 5, 6, and 7, but this can't be 6. One of these is an 8, so therefore this can never be an 8. So this has to be 4, 5 with 3, or 4, 5 with 7. We're not sure which. So 5 has to be one of these two. 5 has to be one of these two. So because of that, we know there's a 5 in row 6 and 7 here. We know there's a 5 in also row 6 and 7 here. So the rest of the row 6 and 7 cannot contain a 5. So these cannot be 5. Therefore, we now have a 6, 7, 6, 7 pair and this can't be 5. So therefore, this can't be 2, which means this can't be 4. So this has to be 3, specifically 3 with 6 and 1. And this 6 can't be a 6, so this is 7, which makes that a 6. And this can't be 7 anymore, so this must be a 5. Okay. This can't be a 5 because of this 5, so this must be a 4, which makes that a 5. Where to tackle next? Probably this Dutch Whisper line. This cannot be 5 because we know there's a 5 either in this one of these two cells or one of these two cells. So this can't be 5 and this can't be 5, whereas the 5 in box 7, it has to be here. So one of these is a 5, one of these is a 5. One of these two is a 5. We're not sure, and this can't be 5. So since that can't be 5, this has to be a 5. So this is 5, which makes this 6, which makes this a 3. Interesting. This can't be 6 because of this 6. The remaining digits here are 1, 2, and 4. So this is 1, 2, and 4. This is 1, 2, and 4. What else do we have? We have... One of these cells must be a 5. Actually, let's figure out what the remaining cells can be in this row. So it could be 3, 4, 5. But this can't be 5. And 8 and 9. And this can't be 8. That's 3, 4, 5. No, 3, 4, 5 is allowed, actually. This has to be 8 and 9, then. So this since this is an 8 and 9 pair, this can never be 8 or 9 here. Because it cannot be 3, 4, or 5 here, because of the 3, 4, 5 in the box, and it can't be 1, 2, 6, 7, so this must be an 8, 9 pair. So this must add up to either 11 or 12 on this region sum line. So 1 can never be on this region sum line. This cannot be 1 either. 5 has to be one of these two. So this cannot be 2, 9. It could be 3, 9. It could be 3, 8. It could be 4, 8. And it can't be 7, 4. So this can never be 4 then. If this were 4, it would have to be with a 7 or 8 to add up to 11 or 12. But 7 is eliminated by that 7, and 8 is eliminated by that 8. So this cannot be 4. So this is 3 or 4, and this is 3 or 4, which eliminates 3, 4 from the rest of the row. And in addition, we have a 3, 4, 5, 6 quadruple. Actually, this can't be 3, so this must be a 6. We do have a 3, 4, 5 triplet now in box 1, which eliminates 3, 4, and 5 from the rest of the box. So this must also be 8 or 9. So this region sum is either 9, 10, or 11. The 1 could be with a 9 to add up to 10. Cannot be 8, though, because there's an 8 here. 2 could be with 8 or 9, or 7. That works. And the 4 cannot be with 5, but could be with 6, or 7 to add up to 9, 10, or 11. So this is 6, 7, or 9. This has to be specifically 1, 2, and 7. So this can't be 1, this can't be 7, because those are the only digits remaining. To add up to 11, this could be 2 and 9. To add up to 12, it can't be anything with 2. For 4, to add up to 11, it's 4 and 7, but there's no 7 possible. So to add up to 12, it'd be 4 and 8. So we have an 8, 9, 8, 9 pair in column 5, which eliminates 8 and 9 from the rest of the column. So it must have 1, 2, 3, and 4 in the remaining cells. But these can't be 1, and this can't be 2. Okay. And this 2 could be with 9 to add up to 11. The 4 cannot be with the 8 here to add up to 12, but it could be with the 7 to add up to 11. And the 9 cannot be with the 3 or the 2 here, so this cannot be 9. So this always adds up to 11, because it's either 2, 9, or it's 4, 7. So therefore this adds up to 11, which makes that an 8. This has to be 9 and 2. So this cannot be 2. This can't be 2. This can't be 8, so this must be 9. This must add up to 11 also. So it has to be 3 and 8. And therefore this is 9, which makes this a 4, which makes that a 3. None of these can be 3. So it's either 10 or it's 11. This cannot be 9 anymore, so the 1 cannot add up with something, so this must be a 4, which makes that a 5, which makes this 4. Oh, and this actually is 6, 4, and 6, 4. Interesting. So this cannot be 4, which makes this a 2, and this has to be 9 to add up to 11. This can no longer have 2 and 8 here. This can't be 2 and 8, so this is 4, 6, and 9 here. Well, 4 could only be next to an 8 or a 9 on a Dutch whisper line, but 8 and 9 are eliminated here, so this cannot be 4. This has to be a 9. And this is next to 4 unique digits on a Dutch whisper line. Since this is 9, this has to be either 1, 5, or 7. 5 can only be next to 2 unique digits, which is 1 and 9. 7 can only be next to 3 unique digits, which is 1, 2, and 3, so this must be a 1 also. And it must be next to 5 and 7. 5, again, can only be next to 1 and 9, so this can't be 5. This has to be 7, and this is 5. The 7 can be next to a 2 or a 3, and the 1 has to be next to a 6 or an 8. And this can't be 6, so this has to be 8. This can't be 9, this can't be 9. So this can't be 6 because of this 6, so therefore this is a 4, which makes that a 6. This can't be 4 anymore. This is 2 or 3. The remaining digits are 1 and 7. This can't be 7, so this must be a 1, which forces this to be a 7. This cannot be 3 because of this 3, and this can't be 3. So we have a 4, 8, 4, 8 pair in column 8, which eliminates 4 and 8 from the rest of the column. Therefore, this has to be 3 and 5. So 3, 5, and 6 can only be a Renban with only the 4 left. This is a 4. This is a 3. This cannot be 3. This can't be 4 anymore, so this must be 8, which makes that a 4. This 8 means this can't be 8, so this is 5, which makes that an 8. This 5 means that it can't be 5, so this is 3. And 5, this can't be a 4, so this is a 1. which makes that a 2, and therefore that must be a 4. This 3 means this can't be 3, so this is 2, this is 3. That's 3 in the corner. We celebrate because we know we're coming to an end. This can't be 2, this can't be 2, so this is 7, which makes that a 1. We have 8 2s. The only remaining 2 has to be in one specific place, and it has to be here, so this is a 2. We have 1 and 8 remaining. This can't be 1, so this must be 8, which makes that 1 in row 4. In row 6, we have 3 and 4 remaining. This can't be 4, so this must be 3, which makes this 4. In row 7, it's 8 and 9, and this can't be 8, so this is 9, which makes that 8. This has to be 7, and we have 7 and 9 remaining, so that's a 9, and this is a 7. And that's how you solve it. Pretty cool fishes. Pretty straightforward, too, in solving this puzzle. But it's pretty cool. I like the fish structure here. It's very interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.